Hello and welcome to Topic 2. In Topic 2, we're going to talk about something that we call the average rate of change. This is not quite yet official calculus, but instead what we're doing here is trying to lay a foundation for what calculus actually is. So in this particular topic, we're going to be exploring the following idea. If you take a graph, a function, and you choose any 2 points on that graph, how can we define the rate of change that takes place on average between those 2 points? And so that's all we're doing. We're just simply finding what happens when we pick 2 points on a graph, figure out how to measure the rate of change, and then we're going to use that as the foundation for the rest of the course. So with that, let's go ahead and get started. So first, let's talk about the objectives for this particular topic. They're pretty straightforward. We want to first talk about and define what we mean by the average rate of change from a mathematical point of view. The next thing we're going to do is explore that in a lot more detail. So the way we will do that in this particular topic is by looking at a very common formula for future and present value of investments and monetary investments. And we will do that in two basic ways. The first one will be by looking at examples of discrete compounding where we earn interest, let's say, once a month or once a quarter. And the second example is through what we call continuous compounding, where we assume that we earn interest on a continuous or in an ongoing way. So we'll look at formulas for both of those, and then once we do that, we'll then use that same set of formulas to talk about how the effects of inflation have an impact on our spending power and our money. So those are our objectives for this particular topic. Let's start off with some examples. So let's start first with a motivating example. We'll come back to this and do some computations on it later, but first let's just see the kind of question that we want to be able to address here. So here's a profit function that we saw back in topic 1. Recall that Q is quantity items sold and produced, and P of Q on the vertical axis is total dollars of profit. So our question here is, if we pick 2 points on this graph, so for example, let's say we pick over here where the quantity is 20 units and measure the profit at that point. And then we pick a different point, let's say it's over here at 50 or 60 units, and measure the profits there. How do we measure the total change in the profits between those 2 points? So that's the kind of question that we want to be able to answer. So let's explore that a little bit more. So let's start by defining what we mean by the term average rate of change. In mathematics, the average rate of change comes from looking at a function, we'll call it f, and picking 2 arbitrary points, a and b, x equals a and x equals b. Typically a is on the left and b is on the right, but it really doesn't matter because they're 2 arbitrary points. And we define the average rate of change between those 2 points to be the slope of the line that connects those 2 points. So the equation that you see here in front of you for average rate of change, or ARC, is really just a slope equation. And the equation that you see here, the f of b minus f of a up on the top and the b minus a on the bottom, might look confusing, but really it's just a slope calculation. So we're going to look at that on the next slide here. But before we get to that slide, we'll just make a quick note that sometimes we call this the difference quotient in a calculus course. So let's take a look at where this equation comes from visually. Okay, so here is just some arbitrary function, we'll call it f. We're going to illustrate what we mean by the definition of average rate of change with the formula on the last slide. So we start by picking a point A on the x-axis. It can be any one we want, but I've chosen this one here for this particular illustration. So what we do is we locate the point on the graph that corresponds to x equals a. So we go up to the graph, we find the point, and then we head over to the y-axis. Now, because this is the function f, the y value at this particular point is the function f evaluated at a. So we would write in function notation that the y value is f of a. Now we do the same thing with point B. Pick another point. It's usually to the right. It doesn't have to be, but it could be anywhere on the graph. So I'm picking this arbitrarily just for this example. Here's point B. We do the same exact thing. We go up to the graph like this, and then we head over to the y-axis to see what its value is. Now again, we are on function f, therefore the y value at this particular point is f evaluated at b. In function notation, that's f of b. So, we define the average rate of change to be the slope of the line that goes through those 2 points. So we want the slope of this line. Well, remember, a slope of any line is simply the change in the y divided by the change in the x, and so you can do a quick slope calculation where you do, okay, the m is the y2 minus the y1 divided by the x2 minus the x1, but in this case, my y values are f evaluated at b and f evaluated at a, so the change in y is f of b minus f of a divided by the change in x, which is b minus a. So that's where that formula comes from. What's most important for you to remember as you do calculations on average rate of change is that all you're doing is computing the slope of a line between 2 points. So let's do some examples of some actual calculations. So let's start with an example that has no context, just so we can see how the calculations work. So we're going to find the rate of change for a function, we'll call it f, between the points 2 and 5. Now sometimes students ask, well, where did you get the 2 and where did you get the 5? Well, I'm just choosing them arbitrarily. The power of this formula and this idea is that it will work for any 2 points that you want. So let's take a look at how this would work. We start by taking the value x equals 2 and using the function formula to determine the corresponding value of y. So to do this, I evaluate the function f of 2, y is equal to f of 2, plugging in the values wherever I see x, I plug in a 2, I do the arithmetic, and then I end up with this point. Notice 2 comma 5 is a point on the graph. X is equal to 2 when y is equal to 5. And the 5 is coming from all of the arithmetic you see above. So that's 1 point on the function. And then we'll do the same exact thing for x equals 5. We will evaluate f at 5. And when we do so, we get this. So f of 5 means plug 5 in wherever I see an x, do the arithmetic, and when I do that, the value is 32. So that gives me a second point on the graph. X is 5, y is 32. So that's all I really need. Whenever I have 2 points, I can always find the slope of the line between those 2 points, and that's all I need to do next. So my next step is to compute the actual rate of change, m. It's the change in y, which is 32 minus 5, divided by the change in x, which is 5 minus 2. Don't forget to subtract the change values in the same order, like we said in topic 1. When we do this, we get 27 over 3, which is 9. So the average rate of change for this function between those 2 points is 9. So now let's go back and take a look at the profit function that we've been working with over the last 2 topics. You can see it here in front of you and the graph is illustrated for you. Our question is, how are the profits changing between 20 and 50 units? In other words, if we were to sell 20 units and then compare it to selling 50 units, what would the rate of change of the profits be between those 2 points? So the question at hand is, what points on the graph correspond to these quantity values? So, for example, these 2 points are the ones that I care about, when q is equal to 20 and when q is equal to 50. We're going to need to know the value of p of 20, or the profit value at 20, as well as the profit value at 50. So we need p of 20 and we need p of 50. And once we have those, then we can simply think of the line that goes through the two of those points, compute the slope of that line, and that gives me the average rate of change between those 2 points. So there's a couple of ways we could do this. We can go ahead and just plug 20 and 50 into the equation using a calculator or a spreadsheet and come out with the answer. Or we could use graphing software to do this. So either way, it doesn't matter. You just need to come up with the value for 20, P of 20 and P of 50. In this particular example, I chose to use software to do the computations for me. So I found that P of 20 was 2,960 and P of 50 was 4,025. So that gives us 2 points on the graph, 20, 2960 and 50, 4,025. Of course, once I have 2 points, I can find the slope of the line that goes between them. So that's the next thing, is to actually do that. Now on the next slide I'll show you a couple of videos on how to do these calculations with software, and then we'll come back to the actual slope calculations. Okay, so now that we have the actual 2 points on the profit curve, it's relatively easy to find the slope of the line that goes between them. So remember, all we're going to do is use the slope formula to do this. So the average rate of change, or the slope, is the change in y, which in this case is the change in profits. So the change in profits is up here. We're going from 2,960 to 4,025. So the change there is just simply the difference between those. So 4,025 minus 2,960 is the change in the profit, or the change in y, divided by the change in x, but x here is quantity. So the change in x here is 50 minus 20. We're going from 20 to 50 units, so the change is a total of 30. So when I do the arithmetic here, I get a total of 1,065 total dollars of change in profit up on top, divided by 30 units of change on the bottom. So that gives me 35.5. And so we want to pay attention to units here, because since this is a rate of change, we can't just say the answer is 35.5. We need to be able to come up with a sentence that says the rate of change is this, and we need to be able to specify what the proper units are. So let's take a look at how we would do that. So for this particular example, we would interpret the 35.5 as follows. We would say that the profits are increasing at an average rate of $35.50 per item when the units sold and produced increase from 20 to 50 units. Now, the profits are increasing because the slope of that line was positive 35.5. So we keep that in mind. Secondly, to determine where you get the units, the dollars come from the vertical axis, and the units sold produced comes from the horizontal axis. So anytime you're talking about rate of change, if you're not sure where the units are supposed to come from, just look at the units on the two axes. It'll always be units on the y-axis per units on the x-axis. In this case, the units on the y-axis are dollars, and the units on the horizontal axis are items or units produced. So visually, this is what we've done here. We've basically located 2 points on the profit curve at Q equals 20 and Q equals 50. We've drawn a line between those 2 points, and we're saying, if you take a look at this line, what is the slope of that line? The slope of this line that we just found from our computations is 35.5. So the rate of change is $35.50 per item sold and produced as the items increase from 20 to 50 items.